Hi friends, I am Shravana and welcome back to my channel Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Friends, in today's video, we will discuss about how the skewed data distribution happens in Spark. So, skewed data distribution, right, it occurs when some partitions of the data are significantly larger than the others. So if you see this example data that is present here, you can see, right, the user ID now for there are two users are here, A and B, and let's say you are partitioning the data based on the user ID. So what happens, 4 records goes to one partition and only the second record, which is B partition, like B's data will go to the other partition. So what happens, the partition that is running that is having the data of user A will take lot of time to process because it has more records than the second partition where for B only single record is present. So in such kind of situations, we will observe the data skewness. Okay, so how to identify whether that there is a data skewness. So now this is, I'm having only the 5 records here. It is easy for us to see, okay, if we like partition it based on the user ID, we will have this. But in real time environment, we will have like lot of records. We can't go by data. It might be in different formats and it will take some time for us to understand the data. And also there might be already running jobs, right? And how can we identify that there is a data skew present in your jobs? Okay, for that what we can do is, what kind of signs we have to check is, while running the Spark job, if you can open the UI, Spark web UI, and go to the stages, right, and you can see some tasks take significantly longer than the others. And for example, not only for example, I mean, it's like you will notice like only one task. I mean, if it has 100 tasks in that entire job, only one task will just stay back there for longer time. Okay, that is one of the signs for this data skewness. And also if you see the executors, like this is my local machine, so I'm not able to show you the UI, but actually it's very easy. You just go to Spark web UI while the production jobs are running. You can just understand the UI and you can see some executors have heavy loads while others are unutilized or underutilized. You will see some difference between the executor memory also in that UI page. And some tasks complete in seconds and others take some minutes. So these kind of issues and all, we can by seeing this itself we can understand that there is some problem with the data, like there is a data skewness present in the data. And how can we fix that? So we know the issue now, like why we are having that slowness in the task, why job is taking lot of time for you. And yeah, if there is a code issue, for example, if you have used some group by, count, order by or any kind of shuffled operations, it will take there are some other techniques that you can use. We have already discussed about these optimization techniques, right? We can apply it, but this especially if there is a data skew, how can we solve this? So mainly first we will, when we are working with Spark, right, we can think about salting. So this AQE is there, but it was introduced in later point versions of the Spark. But before, like you don't have the AQE version, that is like your environment is, production environment is still having the older version of the Spark, then you can go for salting. So I just tried to mimic this. I may not be able to run this code, but I can share you guys this code so you can just try it out. Actually, I have run it and see, like I wanted to show you the UI while running, but surprisingly it is completing within seconds and I'm not able to capture that UI page to show you in the video. But what you can do is you can just try this code and let me know how it works. So if you see here, we have this like I am creating what to say, some random data. Okay, because here to show you the partitions or whatever, I need to have the sample data, right, to show you the how the skew works and why we are having skew, what kind of data we should have with skew, right? So for this I have created normal users and skewed users, two data frames. So if you can see the implementation of these data frames itself, you will understand how the data is present. Only 0 to 1000 in normal users and 2 lakh 0 to 2 lakh users in skewed users. And here we are just assigning some different user ID for both of these data frames, so that we can this example is just to see the difference between like how exactly it works. Okay, now if you see, first we have these normal users where it's evenly distributed. You can see here, right? It's evenly distributed. And the skewed users is where we have this user 999. Only for one user we are appending some content, so that like it will be only for this user ID we will have more records. But here we have evenly distributing, saying that for every user multiple users will be there in this normal user section. But in the second data frame, only for the user 999 we will have lot of data. Okay, now here we are combining it here so that we can make a single data set with, like I'm trying to create one skewed data set. Okay, now we are converting this to data frame and I'm assigning some column headers to whatever we are generating here, right? You can see here, right? Username, like the transaction ID and the transaction date. Randomly I'm generating. If you have a valid data set, you please go ahead with that. You can skip this step. This I have used just for generating or preparing some random skewed data set. And then I'm using repartition here because I'm going to write this to a like file here. You can see here, right? Some skewed data set to that file I'm writing, so that's why I'm repartitioning it here. Okay, and once that is done, I'm also creating a small data set, so that I wanted to, like as I said, right, I wanted to show this in UI to all of you. So I tried to create small data set where the shuffling will happen with the small data set and the large data set. So for that reason I have created a small data set with only 100 0 to 100 and evenly distributed user IDs, and it has only two columns, user ID and the category. Okay, now once that is done, I'm again writing to that small data set. And now we have two data sets. One is the skewed data set, another one is the small data set. Now I have, like once I have write it down to one folder, I'm reading those two data frames here. After reading, I am doing the join here. So at this particular place, right, if you are using the latest versions of Spark, you can see the broadcast join, or if you see the physical plan of your Spark job, you can clearly see that in the joins Spark would have assigned the broadcast join. Okay, otherwise you can actually try that out. Earlier in very older versions of Spark like 1.6 or even like before 2 and all, we used to explicitly mention the broadcast here for the smaller data sets. But now after that, by default the physical plan will be changed to use of broadcast join, and we can actually see that in the DAG as well. Okay, then after the join I'm writing the data set to one data set. So in all these operations, that whatever transformations that we have just done, right, we can clearly see that in the UI while the job is running. We can clearly see how the memory works, I mean how the memory is distributed, how the tasks are triggered, which task is taking more time, everything we can see this. I will give this code, please try to run in your machines and try to open this in like localhost and see the variations, like how the data skew happens. Now so we have the like everything ready, the joint data set is ready. Now we will see because like we have seen, right, we have user IDs, different user IDs, and also user underscore 999, I mean some random number I have taken. So only for the user 999 we have so many records, but other users, like randomly for 1000 users we have only 1000 records. Those are the like normal and clear records. Now what will happen, because now we have this user 999 as a dominant record, right? So it will this partition gets a huge shuffle read size because of this when you are joining with the smaller data set, because every every record with user 999 will go to a single partition, and that single partition will have will have to join with the other things. So this we can clearly see in the UI. Now, how can we fix that? We are talking about the fixes here, right? The first point we have seen, right, how to fix it using the salting technique. As I mentioned, salting we used to do in the earlier versions of Spark, but now we can just enable the AQB. Okay. And maybe in some cases, if AQE is not working for some reason, then also you can try this out. But this nowadays, like AQE work like a charm. Okay. Now we have this data frame created where df salted means from first this skewed data, right? Whatever skewed data set that we have taken, we are creating one random salted key here. If you see here, right, one random key we are using, and we are assigning that, concatenating that random key to the user ID column. User ID column means for whatever, if the user ID is 100 underscore some random number, it will be taken, and finally it is casted to an integer. Similarly, we have a smaller data set just for the joining purpose we have created, right? For the joining purpose, we have created this small salted data set. So for that also, I am performing the same user ID underscore and z0, so that is just very simple one. So my intention here is, when we apply the salting technology, you can see the user ID 999 will be splitted into multiple users now, because the user ID we are changing it. We are just applying some random numbers, and we are creating a new user ID, new column called salted user ID, and now we will join these two data sets. These two data sets here you can see, right, join command using this new column that we are creating in this line, above lines. So now when you compare the task between this join and this join, you can very clearly understand how the data is evenly distributed between the partitions. Okay. These two codes you can use it. So now when you write it back, what will happen? I mean, in the join itself, what you can understand, skew will be reduced because user 999 is now spread across the multiple partitions. Okay. So now this is how we can actually see the data skewness. Okay. Now going back to the video, first one is using salting method that we have seen the code, right? I'll give the code. Please try to run and see how you will understand this. Now second one is using the broadcast joins. So now by default Spark assigns some broadcast joins when we are joining between these large data sets and the smaller data sets. And in case if you have noticed something is not happening properly, you can just go to the physical plan and check it. If not, you can apply that as well. And also we can repartition using the balanced column. Like if you see that in the previous this one we have seen, right? So instead of here we are going ahead with the user ID as the partition name, right? So because of that we see the data skewness in the records that is there. So instead of that we can go for some proper column. If we can take, and we can go for some repartition. We can for a skewed column, like only on if there is a skewed column like user ID, right? Instead of that we can take any proper column, and we can perform the repartition as well. So that because we will have the multiple keys, Spark distributes data across the multiple partitions efficiently. Next is AQV. We all know this, right? This is adaptive query execution. It works very well, and it comes from with the latest version of the Spark. It's by default it's enabled now, and still like before 3.2 or some version in Spark we have to manually enable it. So there is a video for AQV especially. You can go and use the settings for that. If not, also you can just like Spark SQL adaptive enabled to true. If you just set that up, and there are some 3 to 4 options like skew join enabled and many other options. You can see that in the video. And if you enable it, it will help you to auto scale the partitions based on the skewed data will be repartitioned automatically. Okay. So we can clearly see, and even in the UI also, if you can check once this AQE is working or not, you can just go to the SQL tab, and in the DAG, right, you can clearly see one new what to say, node will be created. One new task you can see with the AQE is enabled. Okay, dynamic optimization in the execution plans also we can clearly see when you have enabled this AQE. And this is in the Spark, right? So in case in Hadoop, how are we going to fix this? We can implement a custom hash function which balances the partition distribution. And in case of any BigQuery or cluster tables also, we can use this cluster by, or cluster by we can use, and the key of hashing, like what key you wanted to perform the hashing. For that key you can give the cluster by. And in the Databricks we have hint option, df.hint as q, and the user ID, that also we can perform, and auto optimize option also is there in Databricks. So using all these techniques we can solve the data skew. But as I said, right, go to your production environment and open the DAG for any already executing job. With that, the analysis is going to give you very good understanding of how the tasks works, how much time it is taking, how many records it is reading. Try to understand that, and once you get that understanding clearly, you will be able to solve any kind of problems with the Spark job performances. Okay, hope. And coming to the summary, right, we discussed about multiple issues and the fixes as well. So from the UI, if any task is taking much longer time, then it might be due to the skewed partitions. So we can use the salting technique. This also we have seen, like how to apply the salting technique on any particular column. And if you see that any high shuffle read in few tasks, so how can we see? There is this shuffle read and write options that you can see in the UI. And there if read and write buffer size is not same in the UI, then we can confirm that as uneven data distribution, and we can use the AQB. And sometimes some executors we can see, like some, like lot of memory is being processed and another one is not properly utilized. So that time we can use a broadcast join. And the broadcast join, why I have written if applicable is, there will be small and large data sets join. That time we can use this broadcast join. Otherwise we can just go ahead with the above two techniques. And sometimes in the UI also, right, in the executors we can see the spills, like any buffer spills are there, any memory spills you are noticing in the UI. Then what we can do is we can either increase the memory based on what spill it is showing in the UI, or we can repartition the data. So this is high level, but as I mentioned, you have to understand the UI very clearly while any job is running, right? That's when you will understand, like we will identify where exactly it is going bad, and with that you can take proper action. Okay, hope this is useful to you friends. Thank you for watching the video. Please subscribe to my channel for more interesting learnings. Thank you.